So here you have an example of semi-log paper. Remember that with semi-log paper, each cycle is a power of 10. So we'll say here I have 0.1, here is 1, here is 10. In this case, it's somewhat irrelevant. I am intending only to show you how to calculate doubling time. Remember, at any point that you have a graph with time as one of your variables, time will be your independent variable on your x-axis, and in this case you'll have optical density on your y-axis. Imagining that I had some data that I had plotted. If that data was growing exponentially, then you would have gotten a straight line for the exponential portion of the graph. Remember, your graph will only be growing exponentially during log phase, so you'll have a straight line and then you'll have deviations before that during lag and after that at the transition to stationary. That's fine. Just extend your straight line from log phase so that you have a line long enough to work with. We only want to calculate doubling time for a particular temperature for a particular set of conditions during exponential phase, because that's when the cells are growing the quickest. To calculate doubling time, we'll find two convenient points on our line. So I guess we'll choose here at 0.2. So here's 0.1. Between 0.1 and 1, each line is going up by 0.1. So 0.1, 0.2, 0.3, up to 1, then 1, 2, 3, up to 10, 10, 20, 30, 40, etc. So here I have 0.2. 2 times 0.2 is 0.4. So let me find 0.4, 0.2, 0.3, 0.4. And my line crosses 0.4 right about there. This is not the easiest thing to draw. Then I can just carry those lines down to my time axis. There. I'm going to pretend I can draw a straight line. There. And whatever your time units are, we'll say that each box is 10 minutes. So 10 minutes, 20 minutes, 30 minutes, 40 minutes, and 50 minutes. We'll just see how much time it took to go from something to twice that. So from 10 to here, this is about halfway between 40 and 50, so we'll say this is about 45 minutes here versus 10 minutes here. The time between 45 minutes and 10 minutes was 35 minutes. It took 35 minutes to go from an optical density of 0.2 to an optical density of 0.4. So the doubling time under these conditions is about 35 minutes. And that's all there is to it.